Hey everyone, I'm Joaquin. Catch, Will.
Thanks, Joaquin. I'm Will, and this is our project on the Magnus effect and the effect it has on different sports balls. Sports, what once unified our world, has suddenly all come to a halt as we know it. Soccer, football, bowling, golf, and baseball if you're feeling generous. All these sports use variations of balls. It is important to understand that whether it may be a tiny golf ball or a big basketball, it is the same force acting upon each of them, and this force is called the Magnus effect. So many times in sports, we see balls switch directions in midair as if it's on its own. The knuckleball in soccer, curveball in baseball, and topspin in tennis all seem to defy the simple laws of physics. Why is it that all of these balls, completely different from each other, all experience the same force and can somehow completely change direction in midair? The Magnus effect, that's why. The Magnus effect was first described in 1852 by the German physicist Heinrich Gustav Magnus. However, 200 years prior, in 1672, Newton had correctly described and inferred it after observing tennis players in Cambridge, where he was attending college, and numerous studies have been held since. Our project had the goal of analyzing the Magnus effect on several sports balls. The Magnus effect states that a spinning object exerts a net force on air, exerting an equal and opposite force back on the object, altering its trajectory. It is responsible for the swerving of balls when hit or thrown with spin. Magnus effect affects the trajectory of spinning bodies, regardless the shape or size of the body, and thus alters the direction because of the spin. In the case of a ball spinning through the air, the ball drags air around with it, rushing air on all sides of it. While on one side of the ball there is drag speeding up the airflow, the drag on the side of the ball turning into the air will slow down the airflow, causing it to turn or curve. The ball is forced into the direction of the low pressure region as a direct result of the greater pressure on the side where the airflow is being slowed down. Professional athletes must understand the ways in which the Magnus effect acts on the balls that they use. After observing the bizarre forces acting on different sports balls and researching the Magnus effect, Joaquin and I asked ourselves whether or not the phenomenon was the same for every type of sports ball. We hypothesized that if we compared different balls, then due to the extent to which they spin, the Magnus effect would act the same for every one of them. Joaquin and I each used different sports balls to observe the spin and acted upon them, Joaquin using a soccer ball and myself using a baseball. Here is Joaquin kicking a soccer ball with spin. Here is Will throwing a baseball with spin. This, on screen right now, is the equation for the force due to rotation, aka the Magnus effect. Comparing the video of Joaquin kicking the ball and Will throwing the baseball, we decided to deduce whether or not the forces acted upon the ball would be similar or different. Soccer balls tend to weigh 420 grams and have a volume of 144 centimeters, approximately, giving them a density of 2.1967 grams per centimeter cube. Baseballs, on the other hand, have a mass of 145 grams and a volume of 13 centimeters, approximately giving them a density of 11.1538 grams per centimeter cube. We would have weighed each of our testing products individually for more specific stats on weight and volume, but because of coronavirus, we were unable to attain specific data, thus we are relying on the web for these stats. Since baseballs have higher densities than soccer balls, and each was thrown/kicked with relatively the same velocity, we can deduce that the force due to rotation from both balls was significantly different, thus proving our hypothesis wrong and showing how different balls react differently with the Magnus effect, with density playing a major factor in it.
Magnus effect is not equal for all balls. The density and angular velocity of the balls play a major part in the role that the Magnus effect has on each ball. As we stated before, the soccer ball, when hit with similar velocity, had a greater Magnus effect acted upon it because its density, which was 2.197 grams per centimeters cubed, was lower than that of the baseball, which was 11.154 grams per centimeters cubed. This is evident in our videos, as one can see the extent to which the soccer ball spun, and how it was considerably more than the baseball. This data is relevant in today's society because even the slightest changes in density of the same ball, let alone different balls, have drastic impacts on the Magnus force they experience. This was evident in the 2010 World Cup, where a string of top players from the 32 participating World Cup teams complained that the more lightweight ball was harder to control and much more unpredictable in the air. Even a slight change in the fabrics making up this new ball caused a drastic change on how soccer players felt using it. And although it looked and seemed to be the same as every other ball prior to the World Cup, the decreased density caused there to be more doubts that the ball was unplayable. The importance of the Magnus effect is evident as everyone witnessed the effect it had on the most appreciated sporting event in the world in 2010. Manufacturers are expected to maintain the integrity of each sports ball, and as they saw, even the slightest change made a huge difference. While players may not need to fully understand the physics behind throwing a curveball or knuckling a soccer ball, it is evident that changes to what they are accustomed to with respect to the balls that they play with can detrimentally hinder their ability to perform. Thus, it is quintessential that manufacturers understand the risks behind changing or releasing new balls. In baseball, to compare, balls year in and year out are identical, with the same number of stitches and same texture, whether they're playing up in Seattle or down in Miami. In soccer, different leagues use different balls, forcing players to become accustomed to various types of balls depending on what they were playing with. The visual effects noted as a result of the Magnus effect are always a sight one enjoys to watch, but it is also important to understand the physics behind such incredible feats. Thank you.